Okay, we're back with more systems. Sometimes this section is called fancy elimination. Okay, we have to do some multiplying first, but let's just call this fancy elimination. Okay, because it's still elimination. It just has one or two more little steps in the beginning to get it to work nicely. Okay, sometimes you may need to multiply an equation by a constant, which is a number, to make the coefficients cancel. Okay, sometimes you're going to have to multiply the entire equation. Okay, for example, when I'm looking at this system right here, I'm noticing that they're all lined up ready for elimination, except the x's are not canceling and the y's are not canceling. Okay, I need to have one of them cancel out. I'm thinking 2 and 4 are pretty much related. 1 and 11, that's just getting really big. Okay, so what I'm going to do is I'm going to somehow make this 2 cancel with a 4. I know that if I multiply the entire thing by 2 times 2, he would be a 4. But that still isn't going to eliminate with a positive 4. What I'm going to need to multiply here is, can you guess? A negative 2. Okay, so let's go ahead and write our new system down. The top equation, every term is going to be multiplied by negative 2. Negative 2 times positive 2 is negative 4x. Negative times positive is negative 2y. And a negative times a negative is a positive. Okay, don't forget, especially this is the place where sometimes people don't give the negative 2, and that's where it all goes wrong. Don't forget about that third little thing. The bottom equation, I didn't plan on doing anything. I was just going to leave it alone. So let's see how that looks if we just write the second equation the way he was. They're lined up. Yes. Is something canceling? Yes. Okay. You get to choose the best constant for the system. You get to choose which number you're going to pick and which variable you're going to make cancel out. I could have chosen to multiply this equation by a negative 11 and that would have canceled the y's. But don't remember, everything here would have to have gotten the negative 11. So I chose to do a negative 2 instead of a negative 11. You only want to focus on the variables and you have to make them cancel out. Okay, so I think we're ready for our elimination now. We're going to go ahead and add the equations together just like yesterday. X's cancel. How many y's? 9y. 18 plus 9 is 27. Y is, you got it, a 3. Okay, now we're going to go ahead and plug that 3 anywhere you'd like. Let's try to find the smallest, easiest equation. I don't think the one that has 11s I like very much. The two top equations, this is really just a larger form of the first one. So I think I'm going to choose this original small equation right there. I'm going to plug the 3 into that y spot. That's where I'm going to substitute. You can choose any of these equations. Any of them will work. 2x plus a y value of 3 equals negative 9. Let's subtract 3 from both sides. 2x equals negative 12. Divide by 2. X equals negative 6. Now let's not forget, you can't just leave your work hanging out like this. You have to write the official solution, which is an ordered pair, which means the x number and the y number have to go together like a set. Together they are the solution to the system. Okay, let's keep going. So the only work here is the variables might not be canceling on their own. You might have to think about which ones you're going to make cancel. Okay, let's take a look here. We've got 6 and 2, 5 and 3. Okay, so none of them are canceling the way they are. We're going to have to find kind of like the least common multiple between them. I can't turn a 3 into a 5. I could make them both be 15s. Or how about here, 6 and 2? Is there any way that I can turn one of the numbers into the other one? Like I think a 2 can get turned into a 6, right? If I multiply it by a 3, okay, don't forget to use parentheses. The entire equation is going to have to get the 3. But that is not going to eliminate. A 6 and a 6? Why don't we multiply the entire bottom equation by negative 3? Okay, I think that's going to work. Negative 6x and a positive 6x will cancel out. So let's go ahead and let's just copy this first equation down just the way he is. Okay, don't forget about the constant on the right-hand side. Negative 3 times 2x is negative 6x minus 9y equals negative 15. All right, let's just double check that we are indeed ready to go. Does something eliminate the way it is? Yes, we are good to go. The x's are going to eliminate. Negative 4y equals 4. Y is negative 1. Where would you like to substitute that y value? The top equations are the same either way. And the bottom, the second equation is just a larger version of this original one. So let's try to find the ones with smaller numbers. I vote for that place right there. If you vote for the top equation, you're going to get the same answer as me. You're just going to have bigger numbers to work with. But we will agree in the end, won't we? 2x plus 3 times negative 1 is 5. 2x minus 3 equals 5. Let's add 3 to both sides. 2x equals 8 and x equals 4. So I think that the solution is the ordered pair 4, comma, negative 1. Okay, all right, we got a couple more here. Number 2. Which value should we get to eliminate? Which variable? I noticed that x's have a positive and a negative. I like that. I noticed that the y's have a positive and a negative. Okay, so I guess they're both equally opposites. Now what about the numbers? Is there any way to turn one of them into the other? I could make the y's, if I multiply the top one by 3, a 6, and I can turn this coefficient into a 6, but I'd have to do two things of work. Maybe we should work with the x's. If I multiply this whole bottom equation by the number 3, you got it, I think that would make a negative 6, and that would cancel with a positive 6. All right, let's go ahead and see what the equations look like. We can always erase if we don't like the looks of them. But I'm going to leave the top equation alone. The bottom equation is going to get multiplied by 3. So negative 6x plus 9y equals negative 15. All right, let's see. Is something eliminating? Yes? Then you're good to go. Eliminate. 9 minus 2 is 7y equals negative 14. Y equals negative 2. Okay, we're only halfway done. Let's see. Where do you want to replace the negative 2? The top equation or the bottom equation? All right, let's go for the top equation right there. 6x minus 2 times the y number of negative 2. That's not bad because a negative times a negative, that's going to be a positive 4. All right, this is working out pretty good. Subtract 4 from both sides. Oh, we got a negative again. Negative 3. We're going to divide both sides by 6. Uh-oh, what's happening here? 3 divided by 6, that's going to make negative a fraction. We can cancel by 3. That's going to make negative 1/2. Oh, I don't know about you guys, but I get really nervous when I start getting fractions and decimals. Maybe we should check. Oh, look, let's check our answer here. Okay, so we're going to plug in negative 1/2 for the x and negative 2 for the y. All right, equation number 1. It says 6 times x. My x number is negative 1/2. minus 2 times the y number, which is negative 2. Does that make a 1? Half of 6 is 3, but with a negative. Negative times negative is positive 4. Does 4 minus 3 make a 1? It does. Okay, now don't stop right there because I got negative 1/2 from the top equation. So it doesn't surprise me that it works in the first equation. I really have to make sure that it works in both equations. You're checking the original equation. Don't check over here because what if you made a mistake multiplying and now you're checking a wrong answer in the wrong equation? Of course, wrong with wrong is going to work. We have to check the original problem. Okay, check your answers in the original problems. Okay, negative 2 times the x number, which is negative 1/2, plus 3 times the y number. Does that make negative 5? Let's see, a negative times a negative is going to make a positive. Half of 2 is 1. Positive times negative, that makes negative 6. Does 1 minus 6 make negative 5? Yes, negative 5 does make negative 5. So that is the right answer. I'm going to write it down the solution line. Negative 1/2, comma, negative 2. Wow. Okay. All right, number 5. All right, we're going to see which variables are going to eliminate there. And, oh, wait a minute. I don't think this is even lined up and ready to go. We're definitely going to have to make sure that it's in the right form. The x's have to be underneath the x's. Okay, so let's see. I like the looks of the top equation. So let's just go ahead and write the top equation just the way he is, x's, and then y's, and then constant. Okay, and let's rearrange our bottom equation here. Let's put the x's on the left. Okay, so if you subtract 3x's and subtract 3x's, or if you switch sides, you switch signs, it's going to be negative 3x plus 2y equal to negative 9. Okay, so there's our system. Is anything eliminating? No, nothing's eliminating. So the least common denominator between 5 and 2, I'd have to make the coefficients on y 10s. And I have to do a lot of work. And they're both positives. Here, I'd have to make both of the coefficients. The common denominator between 4 and 3 is 12. So your choice. Do you want to make the coefficients here 12s? Or do you want to make the coefficients 10s? Okay, and it doesn't really matter. Maybe I will do the x's only because one of them is already positive and one of them is already negative. So I don't even have to play with negatives. Okay, but the entire top equation, okay, so we're going to make those be 12s, right? The top equation has to get multiplied by 3 and the entire bottom equation by a 4. Okay, so let's go and write our new system. Okay, this is why it's called fancy elimination. It's taking a little bit more work just to get it ready. 3 times 4 is 12x plus 15y equals, oh no, help, help. 3 times 5 is 15, carry the 1. 3 times 3, 105, is that right? Oh my goodness. Okay, bottom equation. 4 times negative 3 is negative 12x minus 18y equals negative 36. Okay, I'm noticing that the x's are eliminating. Okay, so we are in luck. Let's go ahead and cancel out the x's. 18 minus 15 is going to be negative 3y. Oh no, somebody help me here. 105 minus 36 is how much? 69. Oh, 69 does divide by negative 3 nicely, right? 69 divided by negative 3 is going to be a negative 23. Okay, I feel good when I get nice numbers there at the end. Okay, which equation would you like to substitute the negative 23? Okay, your choice. You can substitute in these equations, but these are the largest of all the equations. These equations here are really just rearranged versions of the original. Let's just go back to the original problem and let's put the y maybe right here. That seems like a nice spot, doesn't it? It doesn't matter where you substitute it. We're all going to get the same value of x. So 2 times negative 23 equals 3x minus 9. Okay, now we're solving for x. This is the solution to y. Our job here is to solve for x. Negative 46 equals 3x minus 9. Let's go ahead and add 9 to both sides. So it's going to be negative 37. Is that working out? Why does it seem like it's so icky? Did I make a mistake somewhere? 12. No, 4 times 2. This is supposed to be an 8. Oh, that's what happened. Did you catch that? Alright, we're going to need to do this work again here. What I really want you guys to do is fix this up here with me, okay? So we can finish strong. 15 minus 8 is 7. And 9 times 4 is 36. Times by 4, times by 4. And that's supposed to be a positive. Oh no. 15 plus 8 is 23. And if we divide both sides by 23, 69 divided by 23, y equals 3. Oh, that seems much better. Y equals 3. All right, I'm going to scratch all this out and try again. 2 times 3 equals 3x minus 9. 6 equals 3x minus 9. We'll add 9 to both sides. 15 equals 3x. Does this seem like it might be the right answer? 5? I think the answer might be 5 comma 3, but I definitely need to check this problem because I made lots of mistakes. Can you please check it for me? And we are going to do the next page in class tomorrow. Okay? Thank you.